So let's go to the 1 byte system. Okay, so 1 byte system, if it's a full 1 byte system, this whole thing is equals to 255, or you can say that it's 2 to the power of 8 minus 1. Alright, or 2 to the power of 8 like this minus 1 if I didn't happen to write properly. Okay, so therefore for a fully utilized 1 byte 8-bit, alright, there's 255 possible numbers. Alright, nonetheless, the highest is 255, the lowest is 0, where everything is 0 over here. Okay, so there is a limitations for an 8-bit systems, right? Because you can only go to 255. The more, if it's 256, alright, the 8-bit system cannot work already. Alright, or if you say that it's going towards 1000, alright, then the 8-bit system can't deal with things like this. Alright, so there is certain limitations for representing certain numbers. Alright, so in this case it's only up to 255. Okay, so if it's 2 to the power of 32 minus 1, if you're talking about 32 bits, alright, this thing will tell you how many bits you are in your subin over here. So you're gonna get a 4 times 10 to the power of 9, or this is something that you often see is 4 gigabytes. Alright, so 4 times 10 to the power of 9 bytes. So over here this is actually 1 byte. Over here this is actually 4 gigabytes. Alright, so yeah, these are all limitations of the numbers that you can represent things. Alright, and therefore, talking about limitations and talking about numbers, you're going to talk about how many things we can represent using all this available storage. Alright, 8-bit can have 255 different representation of itself, or if it's 32-bit, you can have different. You can have 4 gigabytes of a different possibility to store certain numbers. Alright, so therefore this is somewhat a brief introduction to arithmetic. Alright, and you can represent certain numbers, alright, based on how many bit your Arduino can have. Okay, if your Arduino only have 8-bit, then you can only goes up to representation of a 255 numbers and things like that. I will go into details, but this is just a brief summary of a brief introduction, I should say. Yeah, I already blur already. But anyway, so a brief summary of this upcoming videos is that we'll introduce you with unsigned integer, signed integer, and all this stuffs. Alright, where the more we go in, the more you'll get to represent your values. For example, if you have a 254.323396, this particular value is very hard to represent and stores many data and requires many bits, alright, to actually represent this data. Okay, so this data over here, alright, because of there's many decimals and many precision, or the more you go, the more bits you require. Alright, so for the unsigned integer, for this part is only talking about like just now what we have said, maybe you have talking about 255, or maybe 123, or maybe 67. So these are the numbers that can be represented. Alright, for the signed, for the unsigned integer. Alright, so unsigned integer mostly are positive numbers, or the signed integers talk about using your bits, your 8 bits, you can represent a negative numbers also. Alright, and things like that. We'll go through in the subsequent videos. So this is just a awareness for you to fully understand a clear view of what we're gonna do in the subsequent videos, so that you will know that we're approaching a more and more precision, a more and more precise values. Alright, over here is only 1, 2, 3, or maybe 45, some whole numbers. Along the way, this 1, 2, 3 can be represented by 1, 2, 3.33456 whatever. Alright, so the more precision you're talking about, the more bits or bytes you're going to use. Alright, so we're going to talk about it. Hopefully this is a clear introduction, although I know that it sucks. But anyway, see you there.